Now let's recall how we calculated the 6 trigonometric function values for a given angle. So we use the definition, and we need a point on the terminal side of the given angle. So you might want to ask, what if I choose a different point on the terminal side? Do I get different answers for the trigonometric function value? That is the question we want to answer and want to discover. So here, let's look at a case. This case, actually, I showed the sequence of similar triangles in my earlier video. So you want to see that here I have an angle, I call it alpha. Okay, the angle has a name, right? Alpha. So as you can see here. And this angle, we want to decide, for example, 5 different students, and each one picks a different point on the terminal side of this angle. So we have many different choices, right? So suppose I have 5 students and they pick 5 different points. Of course, we can have infinitely many different choices along this terminal side of the angle. But I only show 5 of them. So we know already these 5 points and the coordinates. Let's write the first point. For the convenience of our discussion, I will use a pink, yeah, for the first student. And I would, okay, so let's suppose the first student calculate the 6 trigonometric functions of alpha using the point A on the terminal side. So as we know, A has x coordinate 2, right? The y coordinate is half of x, which is 1. Now we can determine the r, which is square root of x squared plus y squared. So we have square root of 5 for r. Then let's calculate 6 function values. So sine alpha using the point A will be y over r. Y is 1 over r square root 5. If we rationalize the denominator, we get if we rationalize, that means we multiply both numerator and denominator by square root of 5, right? So that is going to be like this. So what we did is to multiply both numerator and denominator by square root of 5, so we can rationalize the denominator. So the answer is square root of 5 over 5 for sine. Then now cosine. Cosine alpha is x over r. X is 2 over r, which is square root of 5. And then we rationalize the denominator by multiplying numerator and denominator by square root of 5. So the answer will be twice square root of 5 over 5. And then we continue, we get tangent alpha, which is y over x, 1 over 2. And cosecant alpha, which is r over y. R is square root of 5, y is 1. So the final answer is simply square root of 5. And secant alpha. Secant alpha is r over x. X is 2. So we have just, so we don't need to reduce it. That's square root of 5 over 2. And then last one is cotangent alpha. Cotangent alpha is x over y. X over y. So 2 over 1 is 2. So now we have found all 6 trigonometric function values for the angle alpha. For the angle alpha, using this point, using this particular point, A, which I circle using a pink. So what if another student wants the point E? Let's circle it in blue. Okay, so let's discover, do we still get the same function values? So we think the sine alpha, if it's a function for the same alpha, we should get the same function value, right? So let's compare. If I use a different terminal point, a different point on the terminal side of alpha. So that is still alpha. I want to find sine alpha using E. But let's say E here, x coordinate of E is 10. The y coordinate determined by this half of 10, right? It's 5. So 10 and 5. And then we simply use this x value and y value, right, respectively 10 and 5, and we need to calculate r value. R will be larger because the xy changing. So then r will be 10 square plus 5 square, and then that's the hypotenuse and distance from the origin to E. So we can calculate, we get 100 plus 25, 125. So that is the XYR if I use the E point. So let's focus on the point E, and then with the XYR values, we can calculate the sine alpha. So let's keep in mind the smaller triangle, right triangle OAA prime, right? And the smaller triangle and the larger right triangle, they are similar, as we discussed in the previous, in one of the previous videos. So they're similar, we can see quickly. That means the ratio of corresponding sides is always the same, constant. So let's think of using E point. If I calculate sine alpha using E, okay, so let's write sine alpha using E. What is the, it's a y over r, right? Y over r. But this y is larger y, which is 5 over its r, corresponding to the previous y over r here, which should be the same because the two triangles are similar. So it's still 1 over square root of 5. Yeah, that means although it's a different point on the terminal side, but we just see that we see two similar triangles. So this the similar triangle, this y over r here, right, in red, will have the same ratio as the small y. If I use a black color, small y over the small r. Yeah, so you see the small y over r using this based on the point A, we already have that y over r equals 1 over square root 5. After rationalization, we have square root 5 over 5. So it's still the same. And cosine alpha, for the same reason, yeah, so we also get cosine alpha is x over r. So let's look at x. So if I go to x, which is 10 over r, this is a larger value. So that is the x over r, which is the same for the smaller triangle. This x, which is 2 over the corresponding r. So that is the value we're still getting. So 2 over square root of 5. After rationalize the denominator, we have 2 square root of 5 over 5. So as you can imagine, we can continue for all 6 trigonometric function values. We will still get the same function values as before. So this is to see the similar triangles. So the ratio will be the same if we're doing the y over r, no matter the smaller triangle or larger triangle you are using, that ratio will not change, right? So that means no matter you are using a smaller triangle or larger triangle, the y over r is always the same. So that will define a sine function. So sine function is only depending on the alpha, the angle. It doesn't depend on which point on the terminal side of the angle. For the same reason, cosine is another function. It is defined as x over r. So x over r, no matter you use a small triangle or larger triangle, x over r, you just have the same ratio, right? Because the sequence of right triangles will form will create the same ratio because they're similar. Yeah, so using this example, you can see why it doesn't depend which point you use. So you should always get a unique answer for a trigonometric function at a given angle.